Alright, so this is going to be your last video for this chapter. So we're going to combine these two learning targets here, which are I can calculate the surface area of rectangular prisms. I also want to add on here, and pyramids. Please add that to your learning target. I forgot to put that on there when I changed it, but we are going to find surface area of rectangular prisms, pyramids, and even triangular prisms at times. Triangular prisms will also be on there, so I guess you should probably write triangular up there also. I forgot to change that learning target. Sorry about that. So you're going to find the surface area of triangular prisms, rectangular prisms, and pyramids. So essentially, you're going to find surface area of prisms and pyramids both. So I guess you could just take out the words and just know that it could be any type of prism or pyramid. Okay, last one here, this is always something we try to focus on, is being able to use this stuff in the real world, because that's really what it's about. Okay, not many people are going to say, hey, oh my gosh, not good. Not many people are coming up to you in the real world and say, hey, find the surface area of this. That's not really going to be what the real world's all about, right? It's going to be an actual surface area problem or a volume problem. So let's go ahead and flip in your notes to page, I don't know, it's near the end somewhere. Try to find it here. Oh, I think that's it. Okay. Again, your learning target's a little off. You can just scribble out prisms and then just add pyramids. Okay, sorry about that. You can blame Sydney Semmel for being at the door. Anyway, calculating the surface area of prisms and pyramids. Okay. Now, the word surface area, and I know you guys have done a lot of stuff with root words and prefixes and suffixes and stuff like that. Just see the wording, okay? It's just the face area, and because it's 3D, there's going to be multiple faces, okay? So for what we're doing, we're going to have 5 faces or more. 5 or more faces is what we're dealing with, and we're just going to find the area of all those and add them together. And that's exactly what I just said here. It says calculate the area of all the surfaces, or the faces, or you could even say the sides. It's another way to say it. Okay, calculate all the sides, and then you're going to add them all together. Now, what they did here is they went ahead and did this for you. I might go through it a little bit, but they went and did the net. Okay, now I'm not going to make you guys do the net and find the area because I don't think it's necessary. Okay, but they did the net. You can see how they folded theirs down. They folded. They kind of flipped this thing on its side, this orange or pink or whatever color that is, that side right there. They folded that down, then they fold the green flappies out, and then just unrolled it from there. Okay. This is just showing you what the dimensions are. Now, I think you guys have learned from me that it's pretty easy to see. Okay, here's my dimensions, or here's my front, so I would call that a front. Okay, and then I would have a back, then I would have a right side, a left side, and a top, and a bottom. And I put them together like that because I know they're going to be the same area. Okay. Now remember that skill I showed you that will really help you is if you go through here and just put your dimensions on there around the shape. Okay. The distance between the top and the bottom here is 10, 10, and 10. Okay. The distance between the front and the back is 5, 5, and 5. And the distance between the right side and the left side is 7 and 7. And that's really going to help you. Okay. Now you can see what they did is they got the top here. This is the top right there. And you can see 7 by 5, just like we just said. You can see it's 7 by 5. Okay. This one right here is what I would call the front. And it would be 10, because all these are 10. 10, 10. And I know that because of this. 10, 10. And then I know that this distance is 7 because I see that this is 7. See how they're doing this? Okay, so now the front I know would be 10 by 7, two-dimensional rectangle. Okay, this one down here, I know that again this is going to be 5 because it's congruent to the top, so I know this is the bottom. Okay, put BO for bottom. Okay, this one here is going to be, we could just call it the right side, that's fine, it just depends on how you would unfold it, but you can see the right side here would be a 5 by 10. Well, that's going to be the same as the left side, 5 by 10. This would be the left side, and then this obviously would be the back. It goes with that one. It's nice that they're color-coded on here so you guys can really see them. Okay? But basically, you would find the area of each one of those rectangles and then add them all together. Well, that's essentially what we're doing here. But I expect to see, when we do these, I expect to see this work every time. So I need to, first of all, write our formulas one more time. The area formula for a parallelogram, remember, is area equals base times height. Please write that. The area formula for a triangle is area equals 1/2 base times height. You need to remember those. Okay? So the front, I look at the front area and say, okay, it's going to be 10 by 7. So that means it's got an area of 70 inches squared. Okay? If the front has that area, then we know the back, because it's being stretched to make a congruent figure. 70 inches squared. Okay, the right side, I can see that it has dimensions of 5 by 10, which is going to be 50 inches squared. So again, it's being stretched from right side to left side, so that would also be 50 inches squared. The top, you can see it's going to be 5 by 7, so that's going to be 35 inches squared. 35 inches squared. The last step then is to take all of these areas and add them up. Okay? 70 plus 70 is 140. Okay? 50 plus 50 is 100. 70 plus 70 is 140. And 35 plus 35 is 70. Now we can just add. Okay? So 140 plus 100 plus 70 is going to give me 210. That's not, I'm sorry, 310, my bad. 310. Okay? So the answer here would be 310 inches squared. And it's squared because we were just doing area, 2 dimensions. Okay? Again, 3 points here. This is going to be, this right here will be 1 point right there, finding the area of each side, each face. The answer will be 1 point in the unit. So 3 points, just like the volume question, just like everything we did last chapter. Okay, this one, finding the surface area of this prism. Okay? So again, we always start right here, guys. Get it figured out right now. And you can put front, back. And maybe you put BA for back. Okay? You have right side. You put it together with the left side because they are congruent. Okay? And the top and the bottom. Okay? And, you know, if you want to kind of just make a little note, I'm going to do it with highlighter. These are congruent. That's why I'm putting them right by side, because that's going to make me remember. I don't have to calculate the area of both of those. Okay? Because they're going to be the same exact shape because they're congruent. So again, if you need to, maybe you go through and write all your dimensions. Okay, I know that this is 3 right here, so that means this is 3. That also means this is 3. Okay, the distance between the top and the bottom is 3. The distance between the right side and the left side over here is 7, so I know this will be 7. I know this will be 7. The distance between the front and the back is 8, so I know this will be 8, and this will be 8. And that's just going to help you really be able to see it, okay? So let's find the area of the front, the easiest one. So it's a 3 by 7. So that means 3 times 7 equals 21 centimeters squared. No need to do the back because I know it's going to be the exact same area. If you need to look at it, you can see right there, 3 by 7, but it is the same area, 21 centimeters squared. Now let's do the right side. I know it's this dimension by this dimension. So it's going to be an 8 by 3. So 8 times 3 equals 24 centimeters squared. Left side again is going to be the same as the right side. The top is going to be right here by right here. So I say, okay, well that's going to be a 7 by 8. So 7 times 8 equals, let me do a different color, 56 centimeters squared. And this is going to be the same, 56 centimeters squared. Okay, so you get out your calculator at that point and you add them up. You're going to get 202 centimeters squared. 3 points right here. Bang, that work, the answer, the units. Go to the next page. Okay, I'm just going to skip this right now. We're not even going to worry about it. Okay, I'd like you guys to please pause, and I want you to do both of these. Find the surface area of both of these problems. Okay, hopefully you all did it and it was easy to you. Hopefully you paused it. But again, you should always start right here. I will not accept the answer if you don't do this work. The front, the back, the right side, the left side, the top, and the bottom. Okay, BO for bottom. Okay, the front, I know it's this dimension right here by this dimension. So maybe I have to do a little work, but the key here, what shape is this, guys? it's a cube, right? Remember when I told you guys constantly, I say don't ever assume anything's a cube? Well, I know that this is definitely a cube because it has all three dimensions the exact same length. The base, this thickness here, and then the height of it, they are all 5. So I know this is a cube. So what that tells me is that I know that this is a 5 by 5. So that's going to be 5 times 5. So I know my area is 25 meters squared. Now, maybe you're all thinking, okay, is Mr. Garrison really going to go through every single one of these? Remember, we got to remember what the definition of a cube is. The definition of a cube is it has 6 sides and all sides equal. All sides are the exact same. They're all squares. They're all going to have the exact same area. So here, there's really, you don't have to do any work on any other one. You see it, guys? Because it's a cube. All the squares are 5 by 5. No matter where you look, you can look at the top. It's a 5 by 5. Okay? So they're all 25 meters squared. 25 meters squared. You find the area to be 25 times 6 is 150 meters squared. Okay? I would still need to see this work. Right there, answer, units. Okay, this one maybe was a little bit more challenging when you did it. Again, front, back. Right side, left side. Top, bottom. Okay? So I do the front. Okay, I know I need that dimension by that dimension. So it's going to be 8 by, this is 6, this is 6, this is 8, this is 8, this is 20, this is 20. You can just see how I'm using this to build that. This is going to be an area of 48 yards squared. Therefore, my back will also be 48 yards squared. The right side is going to have an area of, dimensions of this by this. So it's going to be 6 times 20, which is 120 yards squared. 120 yards squared. Okay. The top is going to be this by this, which tells me 20 by 8. Therefore, it's going to be 160 yards squared. 160 yards squared. Add all these up. 48 plus 48 plus 120 plus 120 plus 160 plus 160 equals 656. Hopefully that's what you got as your answer. Yards squared. Again, the 3 points here for the test. Right there. Answer, units. 3 points on all these. Okay. Let's skip these. I think we've done enough surface area. If you want some extra practice, feel free. Go ahead and practice with these. That's fine with me. They're the same principle, same process every time. Let's go to the next page. Okay. Now let's get into some word problems. Okay, involving volume and surface area. Now you guys already know how to find volume, you know how to find surface area. Now we just got to go back to learning target number 5, if you'll remember, is being able to, where's it at? Being able to decide if it's a volume question or a surface area question. If you guys will remember that, I can't seem to find it here. Here it is. I can understand the difference between surface area and volume, and I can determine which measure to use or which one matches the context for the problem. Okay, so going all the way back to this page right here. One more. All right. I know that now I just got to remember which one's which. Goes back. This connects learning targets 4, 5, and 6 all together. 4 was being able to determine which one to use. 5 was finding volume. 6 was finding surface area. Okay? All right. Now, it kind of gives it away here with volume. But a rectangular tank, or a rectangular fish tank, 60 centimeter, that doesn't even make sense. Bad. This is from the textbook. Write the company because they got bad grammar going on. Okay? But basically, it's a 60 centimeter by 15 centimeter by 34 centimeters tank. All right. So how you got to do this is you have to look, and you got to understand when you're putting something in something like a liquid or something that takes up space, you got to know we're doing volume as it says here. Okay. You got to know that. The thing here that's a little bit weird, and I actually like this about this question, is you have to remember, well, there's one key thing, and let's just find the volume of the fish tank first of all. Okay, let's forget about those instructions for a minute. Let's just find the volume of the fish tank. Now you'll remember that the volume formula, this is a good refresher hopefully, is area of the base times the distance between the bases. Okay guys, you got to remember it like that. It's capital B times H, but you got to remember that this is the area of the base shape. So let's call the base shape this front rectangle right here. Doesn't matter, you could call the top the base, the right side, the left side, doesn't matter. But I'm going to call the front. So I know that this is going to be 60 times 34. Why is it 34? Because I need to know this dimension by this dimension. And I know that's 60, and I know that if this is 34, then this has to be 34. Right, guys? Okay. So that's the first step. So that's just finding the area of the base. Big B is area of the base. Now we got to multiply the area of the base times the height between my two bases. Now since I called my front my base, what is the distance between the two bases, the front and the back? It is times 15. Okay, from here you can use your calculator for this, and it's going to be 60 times 34, which is 2040, and then you multiply that by 15, and you're going to get 30,600. 30,600, of course, would be centimeters cubed. All right. Now that's the volume of the entire tank. Again, 3 points right there. Formula, answer, units. But that's the volume of the tank. This is where you got to be real careful when you're reading. You need to figure out how much how much more water you need. Okay? So there's a couple ways to do this. The first way is to understand that, okay, if it's 1/3 full of water now, how many thirds left are there to fill? Hopefully you're all saying 2/3. And then what you can do is you can do 2/3 of 30,600. This relates back to chapter, I want to say 6. Okay? And this is where you can just do 2/3. And then you're going to do of means multiply. And then do that. 30,600. Okay, so if I do that in my calculator, so I would do 2 ABC3 times 2 ABC3 times 30,600, I'm going to get 20,400 centimeters cubed. Okay, that's one way to do it. Okay, and you can see that's the answer they got. Now, they did it a little bit different than the way I would have done it. Okay, they actually multiplied 2/3 times 34, and then figured out they did 2/3 of the height of it, if that makes sense, guys. Do you all see that? The height of the tank is 2/3. But I just don't, I feel like it's easier if you just do it that way. You know that there's your hole. That's if the whole thing was full, it holds 30,600 centimeters cubed of water. That's how much that's the capacity. That's how much it holds. Okay? But it already has 1/3 of water. So you only want to figure out 2/3 of it. Now the other way you could do it is you could figure out 1/3 of, remember of means multiply, 30,600. You could do it that way, okay, and then you're going to get, when you do that, you will get 10,200, and then you know that number right there is how much water is in there now, because that's 1/3. That's how much water's in there. So then you could take that number and subtract it from 30,600. Okay, there's a lot of different ways. I'm not trying to confuse you by showing you 100 different ways, but I just want you to know that you can do it multiple ways, whatever makes sense to you as long as you show it. So again, to recap, this number right here is the volume of the whole tank. But in the instructions, they already had 1/3 of it filled. So they needed to figure out how much more water would be needed to fill it, which would be 2/3, because 3/3 means the whole thing. Let's go on to the next question. Okay, let's do this one together. So the first step, we're doing volume, so we're going to do area of the base times the height. Okay, area of the base times the height. Okay, here we go. I need to find the area of the base. Again, I'm going to call the front my base, just because, you know, that's just how my mind operates. So I'm going to do the area of this base right here, the front rectangle. which is 25 times 14. And then what's the distance between the two bases? It is 12. So then I do that. I figure out the volume. 25 times 14 times 12 is going to give me 4,200 inches cubed. Again, if this were the problem, 1 point, 2 point, 3 point. However, it's not. You got to make sure you read it real carefully. Find the volume of water needed to fill 3/4 of the aquarium. So you only want to fill 3/4 of it. So I just want to know how much water's in it. So again, it comes back to right there. Look at that. Look at that, guys. 3/4 of. 3/4 of. And then of the aquarium would be the volume of the entire aquarium. Okay? So it's 3/4 of 4,200. So again, this would be multiplication times 3/4 times 4,200. You're going to get 3,150 inches cubed. That is how much. That's the volume of 3/4 of that aquarium. Remember, this volume right here would be the entire thing filled up. That whole thing has a volume of 4,200, but we only want to fill it 3/4 of the way up. Okay. On a test, this would probably be worth 5 points. Okay, and the 5 points would be, I'm going to highlight them in yellow: the formula, the whole volume, the units, and then that volume, the actual volume of the 3/4 of the water, and then the units there. Okay, go to the next page if there is one. Okay, we'll do this last one here. You can see this is a little bit of a funky looking shape, isn't it? This would be a parallelogram prism, wouldn't it? Because a p-gram is being stretched. Make sure you write this. A p-gram is being stretched. So let's find the area here. Now you can figure up the sides, but this is really no different than a rectangular prism as far as we do it the same way. Front, back, right side, left side, and then top and bottom. Okay, so the front here, remember, this 5 is really kind of a distractor right now. Okay, so we're going to find the area of this by doing some investigating on this. Okay, so I know the height here is 4 centimeters. So what's the height back here of the back? It's also 4 centimeters. Well, if I know that this is 8, that length right there, if I know that's 8, then I know that this backside's 8. Because remember, the definition of a parallelogram says opposite sides are parallel and congruent. Okay? So that's why I'm able to know, since it's a prism and these are being stretched, that I know that this is also 8 centimeters right here. This length is 8 centimeters. So to find the area here, I'm going to do 4 times 8 because that's the area of that parallelogram. So that's going to be 32 centimeters squared. The back then would be the same, 32 centimeters squared. Now we're ready to go on to right side and left side. Okay. Okay, well, if the height of it is 4 here, isn't the height going to be also 4 here? I mean, it doesn't change. The height's going to be the same all the way around it, right, guys? All those lines are 4. So I know that my height is 4. Show it as a dotted line. That'd be a little bit better. I'll show it coming down at a right angle, and we know that's 4 centimeters. Now, how do I know what the base is, though? How do I know what it is from right here to right here? Well, again, same definition. Parallelograms have opposite sides parallel and congruent. Okay? So if this is 24 right here, then I know that this is 24. So I'm going to do 24 times 4, and I'm going to get 96 centimeters squared. Okay? Now I'm ready to do the top and the bottom. Okay? So I'm not sure I can do the top. Hang on a second here. I didn't look at this right. Okay, I really can't find the area of this at all because I do not know I don't see a right angle here, and I don't know if we can assume that that is. I don't think we can. So I guess from here we would stop right here because I don't think we can do this. Yeah, I don't think it's possible. I don't think it's possible. So we're not even going to go for it. I thought that had another thing on it, but you guys can understand why. There's no base and height meeting at a right angle. You know it's 24 by something, but I don't know how we can't assume the length of this is anything. Okay, so that's where I guess we stop. Okay, so anyway, you would have gotten this, and then you would have added them all up. Okay, same goes for the volume. You would have found the area of the base, which you could call the front here, which we know is 32, and then we'd multiply it by the distance between the bases, which would be 24. So that'd be your volume. Okay? All right, guys, come in ready on Monday to get after this, but it's the same process over and over and over again. So I'll see you guys.